Hello students, welcome to IMS GATE Academy. Now we are discussing the foundation course of engineering mechanics. Now here today we are at the center of masses. Last class we had been discussed about center of centroid, center of gravity and center of masses also we have discussed, and we have solved two to three examples, and we will go for one or two examples and then we will move for the moment of inertia. Okay guys, hope you understand. Now let us move for the session. Right, have a look on this problem guys, have a look on this problem. So now it is also related to centroid, center of gravity and center of masses. Okay, determine the coordinates of the centroid xc yc of the shaded area from the origin. Okay, shaded area from the origin, that means this is a shaded area. So now this centroid we are supposed to find out. Okay, right. Now options are also given, so try to find out this, guys. Right, I'll give you 1 minute, 1 or 2 minutes time, and then we I'll solve. Here if you are getting confusion, then I'll use to shade the portion, that is right, this is what the shaded portion, guys. So we need to find out the centroid of this, right, only shaded portion. Now in that we have a hole, right, this hole diameter is also given, so hole radius is given, that is 60 mm. Now hole diameter it is yes guys, have you done? Right, now let me solve myself this problem. Okay, right, so here I'm taking guys, I'm taking, so here this entire portion in three parts, okay. So now, so this up to here, this rectangle I'll take the first part, right. Now this triangle I'm taking second part, and this circle I'm taking third part, right. Now if I find the centroid of 1 and 2, if I add them and if I remove the centroid of 3, so that I'm going to get now, isn't it guys, right. Now here the centroid of 1, 2, 3 are there, but here a hole inside the shaded portion is there, that is why I am taking this rectangle as a one part and this triangle as a second part and this circle as a third part, isn't it, right. From here I just add 1 and 2 and then I just deduct the 3 from the 1 and 2, so that I am going to get my centroid for a given shaded portion. Hope you understand everybody, right. Now let us calculate that A1. So what is A1? So now let's calculate the A1. Right, now area A1 is equal to, it is 400 into 150, sorry 125 plus 125, it is going to be a 250, right. 400 into 250 is the area of the first rectangle, that is going to be a so it is 1 lakh mm square, isn't it. Similarly area of the triangle, so it is half B H, half into B into H. Base is how much it is, 150 dimension, and height is again 250, right. Now A2 is equal to, it is half into B is 150 into, it is going to be a 250, such that A2 you are going to get, it is so calculate and let me know, it is 18750 mm square, 18750 mm square, isn't it guys? Now I find A1, A2 and also now let's find out that A3, right. So what is A3? Area pi by 4 d square, right. Now here A3 is equal to, it is pi by 4 d square, such that it is going to be a pi by 4 into 60 whole square, so that you are going to get, it is approximately 11309.73 11309.73 mm square. I am going to get my area of all this I have found. Now here I need to find that, so if I take this as a x-axis, in the problem itself they mentioned that, this is x and this is y, okay, right. Oh my god, this is y and this is my x. All right guys, now so 1, how much the centroid of a rectangle is from x1 y1 x1 y1 x2 sorry x1 x2 x3 we have to find, and then y1 y2 y3 we have to find, isn't it guys? That means x1 means the centroid of rectangle, how much far from it is a y-axis, right. x2 means how much far the rectangle centroid along the x-axis, right. That means from y-axis how much far it is there, right. Now similarly, what is a rectangle, what is a centroid of the circle at exactly from y-axis? So these are the x1 y1 x1 y x2 x3 like that, okay. Now here it is gonna be a, right, now here it is x1 x2 and x3, yes guys, right. So first we will see that what is x1, right. Now x1, right, exactly, so total distance is 400. So we know that exactly at the center the x1 lies, the centroid of the rectangle lies at the exactly at center, so that it is a, what is a y from center is 200 distance, right. Now here it is going to be a 200 mm, right. Now similarly x2, right. So x2 means from here it is going to be a h b by 3, right, it is going to be a b by 3, right guys, right. Now here, so this total distance is 400 and b by 3, that means 150 by 3, right. Now let us go for, it is a 400 plus 150 divided by 3, such that I am going to get my x2 is 450 mm. All right, next similarly x3, right, x3. Now let us see that x3, where exactly the center is lying. So exactly from x-axis it is 200 mm again, right. Now it is going to be a 200 mm, right. Similarly, so find out y1 y2 y3, y1 y2 and y3, yes guys, right, yes, right. Now from here see, so we have find x distance, that is I'll just highlight that with the help of some other ink, right. Now this is my x1 and also this is my x3. Now my x2 is here, right. Similarly, I need to find y1 y2. So from the x-axis, how much my centroid of rectangle is acting, that is come under y1. Obviously it is from base to it is 125, isn't it guys? It is going to be a y1 is equal to 125, because from the rectangle it is bottom to here, it is distance is, this is your y1, right. Now here let us go, and that is one right, it is going to be a 125 mm, right. Similarly, find out y2. What is y2? From here how much distance it is there, okay, right. From there I just wanted to highlight that this distance is your y2, right. So y2 is b by 3, that is h by 3. H by 3 means it is 2 it is going to be a 50 and 250 by 3, right. Now here it is 250 by 3, 250 by 3, then you are going to get, it is 83.33, 83.33, isn't it guys? excuse me. Next, y3. Now the centroid of a circle. So obviously it is going to be a y3 here only, that is 125. Now y3 is 125, isn't it guys? Y3 is 125. Now here, in order to find out xc and yc, we have a formula, right? Now for finding xc is equal to, it is a1 x1 plus a2 x2 minus a3 x3. Why? Because we just add triangle and rectangle, in that we are deducting the circle, so that you are going to get xc, right? From here it is a1 plus a2 minus a3. Now substitute all the values. What is the a1? Now a1 is going to be 1 lakh and 200. 1 minute. 1 lakh into 200 plus a2. A2 is 18750. 18750 into x2. X2 is 400, that is 450. 450 minus, a3. So what is a3? A3 is 11309.7. 11309.7. 11309.7 into, x3. So x3 is equal to 200. x3 is equal to 200. Now it is going to be it is divided by, right? Now a1 plus a2 minus a3. Now what is a1? It is a a1 plus a2, 18750 minus 11309.7. Now if we calculate this, so that you are going to get your xc, that is 243.62. 243.62 mm is a xc. Okay, all right. Similarly, you calculate yc, guys. Similarly, you calculate yc. Please do. Good evening, Reddy. Good evening. All right. Now here, let us move for yc. Calculating yc, it is going to be a a1 y1 plus a2 y2 minus a3 y3 is divided by, it is going to be a a1 plus a2 minus a3. All right, guys. Right. Now here it is going to be a, how much it is? A1, obviously it is 1 lakh into y1. y1 is 125. 125. Oh my God. This is okay. This is mm only. y1 125. This is going to be a 125 plus a2 is 18750. 18750 into y2 is 83.33 minus a3 11309 point something 73 into 125 y3. Now it is going to be it is divided by, right? Now here again 1 lakh plus 18750 minus 11309.73. Now if you solve this, then you are going to get your yc 117.72. 117.72 mm. Okay. Now I'll write it is here clearly, that is xc comma yc. Centroid of a shaded portion is what is that? 243.62. 243.62 comma 11.72, isn't it, guys? Right. Now here, what's your answer? 246, 243.62 and 117. This is your answer B. Okay. Now if you want to locate, then locate this, right. So on x-axis 246, 246 means somewhere here, and 117 means here. Here your centroid of this shaded portion. Okay. So that means all the geometrical center of this particular shaded portion is here. I hope everybody understand. This. Yes, guys. Right. 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 Next is we just go for shift our talk onto moment of inertia. Next our topic is moment of inertia. So what is moment of inertia? Okay, why it is essential? Okay, now let me explain you guys what is moment of inertia. Okay, now first as we define these terms, actually inertia is related to the Newton's of first law. Okay, it is related to first law of Newton's first law. So what Newton's first law states that, okay, so when a body is in rest or in motion, so until unless so a external force acting upon its state not going to be changed. That means if you keep the body in the rest position, and if you unless if you apply the force on that, it will not going to be changed. Its rest state is not going to be changed, right? Similarly, whenever you are applying whenever the body is in motion, then unless you apply the force, external force on it, it is not going to be changed, right? Now it is also related to the Newton first law. Now let me give you the inertia thing. Okay, let me give you the what is inertia. So inertia is nothing but it's a property of body, so which resists the change in state of a body. Okay, which resists the change in state of a body. Okay, are you getting my point? So listen carefully. Inertia is nothing but it's a property of a body which tries to resist the change in state of body. That means suppose a body is in motion. Whenever I apply some opposite force, whenever I am applying opposite force, then it tries to stop. The body motion is going to be stopped. But inertia is a fellow which resists the change in state. That means it resists the motion to change. That means it is going to be stopped. But because of the inertia, it is try to move. Okay, that is what the inertia we are telling. Okay, so inertia is the property of the body which tries to resist the change in state of body. That is what the inertia. Okay, right. Now I just write simply inertia try to resist change in state of body. Change in state of body. Change in state of body, right? And what is moment? What is moment? So that means from these two words I just derive the definition, guys. That is what my intention to tell you. What is moment? So moment is it is trying to rotate the body now. Whenever you apply the force and you fix a point, about that point this force try to rotate the body, right? Now moment is try to rotate the body. Try to rotate body, right? Now under the action of force, right? Now inertia is the fellow which resists the change in state of body, right? So moment is a try to rotate the body, right? Now so by clubbing these two statements and develop a statement of moment of inertia. So moment of inertia definition is okay. Right. Now let me give you the definition. Right. Moment of inertia is the property of the body, so which tries to resist the moment on the body. Okay. So that is what moment of inertia. Okay. So what is that moment of inertia? Moment of inertia is the property of the body which describes the how much resistance the body the body have to resist the moment. Okay, to resist the moment which is applied on the body is come under moment of inertia. Right. Now let me give you the definition, guys. Okay. Right. Now moment of inertia is the property of body. Moment of inertia is the property of body which describes how much body have resist, how much body resists moment that is applied. How much a body resist moment that is applied on it. That is applied on it. That is applied on it is come under moment of inertia. Is come under moment of inertia. Right. If suppose a body having higher moment of inertia, if the body having high moment of inertia, then it can resist more moment which is applied on the body, right? If the body have not if the body having less moment of inertia, it means that the body cannot resist the moment which is applied on that. Okay, are you getting my point? Suppose say that this is a body and if I apply some moment on that, so if this moment is resisted so very highly, then we can say that this body having high moment of inertia, right? If the body cannot resist moment which is applied on that, then we can say that the body is said to be, it is having less moment of inertia. Clear everybody guys? Clear everybody guys? Okay. Right. Next is area of moment of inertia or moment of inertia of area, right? So next terminology is area of moment of inertia. Moment of inertia, MOI means moment of inertia of area, right? Most of the times moment of inertia, MOI, we indicate of area. Okay, it is also known as second moment of area. Okay, moment of inertia of area we can also call second moment of area. Second moment of area. Okay, it is also known as wait. It is also known as second moment of area. Second moment of area. It is also known as second moment of area. Okay. Okay. Right. Now let me describe you what is moment of area. Okay. So it is a geometrical property of a body. So how much particles are distributed about an axis is come under moment of area, moment inertia of area, right? So I just give you that definition again. Moment of inertia of a area is nothing but it is a geometrical property of a body. Geometrical property means it is depends upon size and shape, right? So material properties means that depends upon the material, right? It is a geometrical shape of material, okay, which describes that so how much of particles, how the particles are distributed so among a axis or with a reference axis, how the particles of area are distributed is come under moment inertia of area. Okay, so it is a geometrical property of an area, right? Now let me write that. It is a one minute guys. It is a geometrical property of an area. It is a geometrical property of an area. It is a geometrical property of an area which describes how the area of particles distributed how the particles area of distributed, okay, about an axis. Isn't it guys? Okay, now I'll show you that, not a problem. So it is a geometrical property of an area which describes how the area of particles are distributed about an axis is come under, you know, moment inertia of area. Okay, so be in a line guys, I'll be back. Yeah, I said it is a second moment of area. Now let us see that how the second moment of area will be there. Okay, right. Now in that case, now I'm taking a area. Okay, so I'm taking an area which is certain distance from the x and y axes. Okay, say that it is a x, say that it is a y, it is a x and y axes. Okay, now here this area, see, this area is certain distance from the x axis, say this distance, say x, and it's is concentrated, the area of centroid is c. Okay, now here how can we write first moment of area? How can we write? Right, now this is a assumed area, this is a assumed area, right? Now this area, center of gravity or centroid, is at C point and it is located certain x distance from the area, right? Certain x distance from the area, right? Now see, now here first moment of area, how can we calculate first moment of area, right? Now first moment of area, first moment of area is equal to, it is gonna be a, how can we calculate first moment of area? So area into x, area into x, right? Now similarly, how to calculate that second moment of area, right? It is gonna be a second moment of area. So second moment of area is nothing but it is area into x square, that's it, area into x square, that's it guys, that is a second moment of area. Okay, right. Yes, yes, thank you Gaurav sir, good evening. Right, now this is second moment of area. Now here I gave you an definition for the, it is also known as second moment of area, and then I gave you the definition. It is a geometrical property of an area which describes how the area of particles distributed an axis about an axis. Okay, right, now let us see that, and I am considering one certain area, I am considering certain area, say this area should be like this. Okay, now say this is area 1. Okay, now in that I am taking a reference axis, I am taking a reference axis. Okay, now it is called reference axis, reference axis, isn't it guys? Right, now this area, it is having small particles. So how they are distributed about an axis, right? Suppose say that here so many particles are there that are distributed like this about an axis. The area of the particles are distributed like this. This is called, area of particles, area of particles, right? Now similarly, whatever the area A1 I am considering, this area I just vertically drawn. Okay, I just drawn vertically. Now look at here, right? Here I am taking reference axis like this, right? Here it is reference axis. Now here this area is also A1. Both areas are equal, but the thing is here, one time I have taken particle distributed horizontally, now one time I am taking a vertical axis, and how the both are vertical axis only. But if I take vertical position of the shape of the area, then how the particles are distributed. Now see here, the particles are distributed right, particles are distributed like this. Now if you observe here, the particles are very close to the axis, right? Here if you observe that the particles are distributed so far from the reference axis, isn't it? Right, now whenever particles are distributed so far from the reference axis, then that we consider it as it is having high resistance, so that it is having high moment of inertia. I hope everybody understand, right? The particles from the reference axis distributed so far, then it have higher resistance to moment. So if you apply the force on that, it tries to resist the moment. That is why when the particles are distributed so far from the reference axis, then that area having high moment of inertia, right, as compared to this one. Now you tell me that here the particles are distributed very small area, right, so very close to the reference axis. That is why these particles or this area not having much resistance on the moment, right. Now we can say that this area is having less moment of inertia and this area is having high moment of inertia, right. Now here I'll write it here, right, high moment of inertia of area. Why? Because the particles are distributed so far from the reference axis, right. Now here low moment of inertia of area, right. So why? Because the particles are distributed very close to the axis. That is the two reasons, guys. That is the two reasons. So now I hope everybody understand. Right, guys? Right. Now let us go for right. Now here I'll give you when moment of inertia comes into picture. When moment of inertia comes into picture, right. Now suppose I am taking a rectangle, right. Now say that it is fixed at this position. It is fixed at this position, right. Right, guys. It is fixed at this position. This is a rectangular bar. Okay. Now here, so I am taking this point is A and this point is B and this point is C. Now here, if I cut this body, at B, now see, suppose say that here I'll apply a load over here, right. I'll apply a load over here, say that P, okay. So P is a force which is applied like this. Now if I draw this, then what happened? So now again here this is a force P, right. Now whenever I cut that, some internal forces are going to be acted onto the body, na, isn't it? Because it is pulling this side. So that is why some internal forces are going to be acted upon over there. Now here let us see that, this is what, so these internal forces are equally distributed. These internal forces are equally distributed on the axis or at the end, okay. So this is what happening. Now we will see that similar type of example, okay. Now here, so now here if I apply the force over here, now internal forces are equally distributed. Internal forces of body after cutting, right, equally distributed. Isn't it, guys? Equally distributed, right. Now let us go for another thing. Now in place of force, if I apply moment, right, it is also fixed over here, right. Now here let us take that, right. Now this is a point, this is a B point and this is a C point. Now similarly here also if I cut the portion at B, now in this case what happened, here I am applying a moment, right, not force. So whenever I apply the force, because of that, if I cut that, because of that forces, the internal forces of the body are equally distributed, right. If I apply a moment, then what happened to the body? Let us see that, right. Now see here what happened now. So again I'll take the shape and show you that. here you have applied a moment. You have applied a moment, say m, right? So because of this moment, then what happened na? So the internal forces are not equally distributed. So they are going to be distributed like this, linearly, right? They are not equal, right? Now they are not equal like that. So internal forces are distributed like this, like a linearly they are going to be distributed. Clear everybody, guys? So that is what the difference between whenever we apply the force, whenever we apply the moment. Okay, now so this moment of inertia we are trying to use to resist the bending moment as well as the twisting moment. That is what I would like to conclude by giving you this. Okay, now what is a moment of inertia? Moment of inertia is the property of the body which resists the how much it resists the moment applied on the body. Suppose say that here I am applying some moment on the body. So right now here this body, how much it is resisting this moment is called it as a moment of inertia, right? If I apply the force like this, then in order to differentiate that, whenever you apply the moment, whenever you apply the force, then what happened to the body whenever it is undergone under the action of forces, under the action of moment. That is I would like to show you. That's what all about this slide objective. All right, guys, right? Hope you understand. Hope you understand. Right now, let us move for next concept is how to calculate moment of inertia of area or area of moment of inertia. So now calculating moment of inertia of area, right? This is our concept, how we are going to calculate that particular fellow. So for that I am going to take two axes. So I want to calculate the moment of inertia of this particular shape. This particular shape I would like to calculate moment of inertia of area. How to calculate this? Okay. So now here this is my x-axis and this is my y-axis. Okay. This is my x-axis and this is my y-axis. Oh my God. Oh my God. I'm so sorry. I'm so sorry. It is x. Right now, for that purpose, what I do now, I'll consider a small elemental area. I'll consider a small elemental area in this. Right? It is very less than, guys. Okay, it is very less than. All right. Now from here, see, this is a distance of. I'll take another color. Right. Now this is. It is dx. Now this is say dy, isn't it? Right. Now this elemental strip fellow is so how much far it is from here? Okay, it is gonna be a x and it is gonna be a y distance it is located. Now if I want to calculate this fellow, so suppose if I integrate that, so that I am going to get moment of inertia of about x-axis, right? Now here dA is equal to, it is dx into dy. What do you say, guys? dA is equal to dx into dy, right? Right. Now here let us moment of inertia about x-axis. Moment of inertia of about x-axis. Moment of inertia about x-axis. Right. Now here x-axis, Ix is equal to, it is gonna be a, right? Now moment of inertia about x-axis is equal to, it is gonna be a integration of y square into dA. right? Similarly, moment of inertia of, about y-axis, about y-axis, it is going to be a Iy is equal to, it is going to be integration of x square into dx. So this is how you need to calculate that. So this try to resist the bending moment. They tries to resist the bending moment, right? I will just show you that. Alright guys, like that we can calculate the moment of inertia of the particular one. Alright guys, done. Now let's move for another thing is another important terminology, that is polar moment of inertia. Polar moment of inertia. Polar moment of inertia. Polar moment of inertia. Yes guys, how to calculate polar moment of inertia, right? Now for that, again I am going to consider a small area, right? Now again I am taking, this is my x-axis, sorry, y-axis, and this is my x-axis, and this is my y-axis, right? Now here it is gonna be a, so small elemental area, say dA. Okay, now I'll write it is inside only. I'll write it is inside only. I'll write it is inside only. All right. Now here guys, what happened now? It is located from x-axis x distance, from the x-axis it is distance located y distance, right? Now here guys, what happened now? Now how about y-axis, z-axis? How about z-axis? It is located certain distance from the z-axis. So that is, we call it as a r. That we call it as a r, isn't it guys? Right? Now I'll write my r. I'll write my r through the Pythagoras theorem, right? Now r square is equal to, can I write it as x square plus y square? Yes guys, can I write it as x square plus y square? See here, it is r square is equal to x square plus y square. So if I consider this triangle, this is x, obviously this is going to be a x, so that I can write it as r square equal to x square plus y square, isn't it? Now if I wanted to calculate the moment of inertia of this area about z axis, right? If I wanted to calculate moment of inertia about z axis, and it is integration of r square into dA. Yes guys, isn't it, right? So from here I can write it as Iz is equal to, it is going to be a integration of x square plus y square into dA. Clear everybody guys? Clear everybody? Right. Now from here Iz is equal to, I'll write it is integration of y square into dA plus integration of x square into dA. Yes guys, now here I can write it as moment of inertia about z axis is equal to moment of inertia of x axis plus moment of inertia about y axis. Okay, so hope you understand. So this called polar moment of inertia, right? If you take the moment of inertia, right, here it is not visible na? Now I'll write it is properly in the next axis. Next polar moment of inertia, polar moment of inertia is equal to, it is going to be a Iz is equal to integration of y square into dA plus integration of x square into dA. All right. Now this I can write Az is equal to, now it is going to be a, so integration of moment of inertia about x axis, moment of inertia of y axis, right? This is called polar moment of inertia, right? This is called polar moment of inertia, called polar moment of inertia. Polar moment of inertia. Clear everybody guys? Hope you understand, guys, hope you understand. Next is parallaxis theorem. Next is parallaxis theorem. Right. So now I hope you understand. If you want, you can go for this for a while. All right, guys. Now let's move for parallaxis theorem. Parallel axis. Parallaxis theorem. All right. Now, what stating parallaxis theorem? I just don't want to go for a statement and prove all these things. You just remind that in a simple way, in shortcut way, I'll explain you, and with the help of diagram, I'll explain you. You just remember it. Okay, right. Now here I'm considering an area. I'm considering an area, right? Now here, so this area having moment of inertia on this particular one. Okay. Now I am considering area. I am considering an area, right? This is a moment of inertia of this area about this point, right? Now similarly, I have another axis. Right. Similarly, I have another axis. Right. Now this is what? Right. So I have a center over here, say, right? I have a center over here, and these two axes are separated by a distance called d. Separated by a distance called d, right? Now if I wanted to calculate moment of inertia about this axis C1 at C1, right? This is a C and this is a C1. Now here I can write my moment of inertia about C1 is equal to moment of inertia about C plus A into d square. This is what the parallaxis theorem, right? If you know that moment of inertia about this point, about this for this area, and if you want to calculate the moment of inertia about the another axis on the same point, then so you can write your parallaxis theorem. So moment of inertia about this point is equal to moment of inertia plus moment of inertia about this point plus area into d square is a fellow. So this case we can apply in a solving the problems. All right, guys. Hope you understand. Hope you understand, guys. Now see, I'll give you that some examples of how to calculate the moment of inertia. Right. Have a look on this. Right. Now take this formula and we will use this for solving the problems. Right. This formula we will use in the problems. Okay, this is pi d for 4 pi d power or 4 by 64, guys. I'll write it is pi d power 4 by 64 for circle. Pi d power 4 by 64. Pi d power 4 by 64. Yes, guys. 4 by 64. Yes, right. Now see that for rectangle, moment of inertia bh cube by 12. Now about this axis, about this center axis. Okay, from the bottom if you want, then you need to apply parallel axis theorem, isn't it? Right. Now triangle. So from the triangle centroid axis, for the centroid axis it is bh cube by 36. bh cube by 36. Right. Next for circle it is pi d power 4 by 64. Apart from these three, I will give you certain shapes also. Halo circle as well as I section and T section I will give you. All right. Right. Now here halo circle. How to calculate the moment of inertia of halo circle? Halo circle. Now for halo circle, now let me go for the shapes. Right. Right. Say this is my center of these two. Okay. So one is the inner circle, another one is a outer circle. Yes, guys. One is the inner circle, another one is the outer circle. Say this diameter is d0 and say this diameter is di. Say this diameter is d0 and this diameter is di. Okay. Now if I wanted to calculate moment of inertia about x axis and y axis, right. Now if I wanted to calculate moment of inertia about x axis and y axis for this halo circle, right. Now so Ixx is equal to Iyy is equal to, it is gonna be a pi by 464 pi by 464 sorry pi 65 by 64 and d naught power 4 minus di power 4. Clear everybody, guys? So like that you are supposed to calculate. Clear, isn't it? Now here this is the halo case, and here the difference between the outer diameter inner diameter is a little bit large. Okay, the difference between the d naught minus di is a little bit large. Okay, now if suppose there is a lot of very less difference between the inner and outer diameters, then what happened to the moment of inertia? Now let us go for and see that case also. This is case 2. Say this is a case 1. Right. Now here if I select another circle, right. Now suppose say that this is a halo circle which is having less thickness. Okay, now say this is a thickness. Say this is a thickness, isn't it, guys? This is a thickness. Now, so now here this is what the diameter. This is what the diameter right, diameter d, right. Now here if I wanted to calculate the moment of inertia about x axis and y axis, if I wanted to calculate the moment of inertia about x and y axis, right, now x and y. All right. Now for this case, Ix is equal to Iy, moment of inertia about x axis and moment of inertia about y axis is equal to, it is pi d cube by t, pi d cube t by 8, pi d cube by t by 8. Now here you need to remember guys, it's a very important. So t is very less than d, right. So t is very less than the t. Okay, hope you understand guys, hope you understand, right. Now let us go for solve some problems. Right, have a look on this guys, have a look on this problem, right. Try to solve. Now here it is 20 mm, here I guess it is not visible to you, this is 20 mm only, and this is 100 mm only, this is also 20, now this is 100, this is 20, now this is gonna be a 200. All right guys, right. So try to solve this, I'll also solve, not an issue, you try for 1 or 2 minutes, then I'll solve. Right. Now read the problem carefully guys. Find the moment of inertia of section shown in figure about centroidal axis xx perpendicular to the web, okay, perpendicular to the web, okay, right. Now here it means that okay, we need to find out, so your centroidal axis about perpendicular to the web means this is, right, we need to find moment of inertia about this point, so about this axis, clear everybody, right. So about this axis we need to find, right. Now here, so in order to this, your x axis will come, your x axis will come here like this, x, right. Now here it is this is your x-axis, and here it is, y, right? Now, obviously, your centroid lies in this particular point, right? That means no need to calculate the x. So, you need to calculate only y. So, if you calculate y distance and then find the moment of inertia of this body. Alright guys, right? Now, first find out the centroid of that particular fellow. Centroid of that particular fellow. Right. So, now this section is divided into three parts. Have a look on this, three parts. It is divided into three parts. Say it is a part 1, say it is a part 2, and say it is part 3. Isn't it guys? That's a part 1 and say it is part 2 and say it is part 3. Three parts it is got divided, right? Now, I will make a small table, okay, here. So, first area. So, now first area. So, before that I will take a line. Right. Right. So, here I will take 6 columns guys, and it is going to be a 1, say 2 and 3, say 3, right, and 4, 5 and 6. 6 columns I have taken. So, in the table format we will solve this problem. Okay, right. So, now what they gave that, see, first we will find out the moment of inertia of this entire body about 1, 1, right. But we do not require moment of inertia of body at 1, 1. We require a moment of inertia of this entire body about x-axis, we require. That is why here we need to find out the moment of inertia of entire body about base, and then we will apply parallel axis theorem. So, how to apply parallel axis theorem? So, this distance, this distance, centroidal distance into area, so that you are going to get it as a moment of inertia of this body about y axis. Hope you understand guys, hope you understand, right. Now, let us go for, so first areas will calculate. So, area of component 1. So, what is the component? ABCD component, right. Area 1, component first. So, now here component right. Next is here it is going to be a area, right. Next is centroidal distance from y axis, centroidal distance from I section, that is bottom. From the bottom, what is the centroidal? Y axis, okay, right. That is come under, it is y, it will come y, right. Next is AY, that is area into y, okay. So, now here AY square, okay. So, and then moment of inertia of self, that means each part moment of inertia will calculate here over there. Alright guys, hope you understand, So, first component is ABCD component and its area 20 by 100, right. Now, first component is ABCD component. Now, we will take say here first component is ABCD. Is it visible, this color? Let us see. No, it is not visible. We will change it. Right. So, first component ABCD, its area. So, it is 100 by 20. That is going to be a, how much it is, guys? It's a 2000 mm square, right? Now, so first port centroidal. Now, what is the centroidal of this first port? Obviously, it is going to be a center. That is, here it is from bottom to 10, it is 10. Now, 20 plus 100, 120 plus 10. How much it is? 130. Yes, guys, 130, isn't it? So, from here, here the centroidal of the first part, ABCD part. This is a ABCD part and its centroidal is here. Now, this distance is exactly 10. So, 10 plus 100 plus and 10. So, now it is going to be a 130, right? Now, it is going to be a 130, right? Now, centroidal distance is y1 is equal to 130, right? Now, we are taking component ABCD is a 1, right? Now, AY. Multiply these two. So, if I multiply this area and this one, then I am going to get it is 260000. 260000 I am going to get. Now, here this into again 130 you do. This into again 130 you do. That is, you are going to get it is 3380000, right? Now, it's a moment of inertia. BHQ by 12 na? BHQ by 12. So, what is width? So, now here it is BHQ by 12. That is going to be a 100 into 20 cube by 12. So, it is going to be, it is equal to, you are going to get it is 66667. 66667 mm power 4. Alright, guys. Right? Right. Now, similarly, so find out that second body, second port area is this width is 20 and is 100. So, 100 into 20 into 100, right? So, what's the port name? Port name is EFGH. Second port name is EFGH, right? I will change this. Second port is EFGH, right? Now, here it is going to be a 20 into 100 again. So, it is going to be a 2000 mm square. Here it is, here only we will write mm square, right? Now, let us decide that it's a centroid. So, for this centroid, obviously this centroid block is exactly at 50, right? So, for this block exactly at 50, right? So, from the 50, this up to here it is 50. Now, 50 plus 20, it is going to be a 70 exactly, isn't it, guys? Right? Now, here y2 is 70. This is equal to y2. Now, here 200 into 70, then it is going to be a 140000 will come. Now, if I multiply 70 into again this one, then I am going to get it is 98. This much I am going to get. Now, here what is the moment of inertia of this? What is the moment of inertia of this? Now, the moment of inertia of this block is again BHQ by 12. So, right now here BHQ by 12, if I write that, then it is going to be a 20 into 100 cube by 12. This is equal to, it is going to be a 1666667. 1666667. Yes, guys, right? Now, similarly, right? Now, JKLM pot. Right? Now, here JKLM part. So, now its area. So, now see the area. It is 20 and it is 200. Now, here it is 20 into 200. That is going to be a 4000 mm square. Right? Now, decide this. Right, decide this centroid. So, obviously, I know that my centroid is here exactly at the bottom from here half of the 20. Now, it is going to be a y3 is 10, right? Y3 is 10. Right, now here 10, that is equal to y3, right? Now, if I multiply these two fellows, then I am going to get it is 40,000 right? Now after that I am going to get it is 0000 I am going to get. Now let's BH cube by 12 again, that is going to be a 200 by 20 cube by 12, such that I am going to get my moment of inertia is 1333.33. 1333.33 guys, 1333.33. This is what I have calculated. So moment of inertia for self of the each body, moment of inertia, its centroid and its area, and I have calculated. So in order to find out the ay square also I have calculated, because we need to apply perpendicular axis theorem na. For that purpose, total area into y square, if I manipulate this, so that I am going to get it, isn't it guys, right? So that is why I have calculated all these. Clear everybody, right? All right guys, right? Now I hope everybody understand, right? Now let us find the centroid of a section. This total centroid of section we have to find, right? Total centroid of the section from base. Centroid of section from base. Centroid of section from base, isn't it guys? Now from here I'll write it as, so YC is equal to, it is three sections na, A1 Y1 plus A2 Y2 plus A3 Y3 is divided by A1 plus A2 plus A3. Yes guys, understood, right? Now here A1, so how much A1 we got? 2000, A2 is 2000, A3 is 4000, right? Now here it is 2000 into Y1, 130, it is 130. Now again it is A2 is 2000 into 70 plus it is gonna be a oh my god, it is 2000 na? Right? Now 4000 into 10 is divided by, it is 2000 plus 2000 plus 4000, isn't it guys, right? So from here I am going to get my YC is equal to 55 mm from the base, 55 mm from the base, right? Now I got to know that my centroid is 55 mm from the base. This is my YC. Clear everybody guys, right? This is smart YC, right? Next. Right? Right. Now let us find that moment of inertia of a total section from the base. Moment of inertia of the total section from the base. Find out that. Right. Moment of inertia of section, MOI of section from II. All right. From there, I'll write it as III is equal to, it is sigma moment of inertia of self of all plus sigma AY square. Sigma AY square. Okay, that means all three moment of inertias, all three sections moment of inertias, all three section moment of inertias, AY square means all these. Okay, now here I'll write it is AY square, total AY square is equal to, it is gonna be a 44, so 00, 00 and 00, 44, 00 and 00. All right. Now here, if I add all these, sigma I self, that means this plus, this plus, this plus. Okay. Now I self, I'll calculate it, not issue. So now here I self is equal to sigma I self, that means that is I1 plus I2 plus I3 is equal to, it is going to be a, so I1 is 66667 plus I2 is 1666667 plus I3 is equal to 1,333.33. Isn't it, guys? Right? Now, if I add all those, now my sigma LF is equal to, it is gonna be a 1,866,7 I am going to get. So as we have calculated AY, so what is sigma AY square? Sigma AY square is equal to, here we will use capital because in the past case also we have used a only there. Okay, right. Now here let us go AY square, right. Now sigma AY square is equal to, now here what happened, 4 this one. That means sigma AY square means sigma AY1 plus sigma AY2, AY1 square plus sigma AY2 square plus sigma AY3 square. That's it. A1 Y1 square plus A2 Y2 square plus A3 Y3 square. So that you are going to get it is a sigma AY square. All right. That is 44 00 00 00 I'm going to get. Now here I'll get the moment of inertia of total section from base, right. Now here I from 1 is equal to sigma I self plus sigma AY square. So that is equal to sigma I self, how much, right, 18666.7 1866667 plus this fellow 4400 00 and 00 I got. Now from here I'll get my this section is 4586667 4586667. So see guys, I don't think that the problem is very lengthy, but the thing is here what I'm trying to do that for giving the practice of that I have taken lengthy problem. All right, right. Now let us go for II. Now if I apply parallaxis theorem here, right. If I need the moment of inertia of IIX, I got moment of inertia from base, I got. Now I will apply this moment of inertia, right. Parallaxis theorem I will apply, that is equal to parallaxis theorem. According to the parallaxis theorem, I11 is equal to, it is going to be a IXX plus a sigma AY square, sigma AY square, sigma AY square, right. Now I know that I know sigma AY square, I know. Now here I'll write it as sigma XX is equal to, now it is gonna be a I minus sigma AY square, right. Now from here IYY is equal to 458 666 minus, right, minus AY 44 00 00 00, right. Now here I am going to get my IX is equal to, no, it is I'm sorry guys, here sigma AY square means, okay, fine, no issue. Sigma AY square means, okay, Now here this area, total area. So now total area into YC. Now what is the total area? So total area 2000 plus 2000 plus 2000. So that it is a sigma A is equal to, it is how much it is? 8000, right? Now from here it is going to be a sigma AY square na. So sigma AY square means here it is 800, here it is YC square, right? Now here it is going to be a, it is 8000 into, so YC is 55 we have found na, right? From there I am going to get my moment of inertia about XX axis is 21 7 mm cube mm power 4. This is what you are going to get, guys. Okay, now see what I have found so far. Okay, right, I just briefly explained you guys. Okay, now actually we require to find out the moment of inertia about XX axis. For that what I have done, I found the moment of inertia of from the base of this entire section, right? So that is I got I11, right? Now if I want to this, then what I do, I'll apply perpendicular axis theorem. That is the total area, that means Ixx is equal to I11 is equal to Ixx plus AYC square. So that is the coordinate, that means exactly centroid of the point. So total area into YC square, that is what I have applied. Now in order to find out I11, so individually I calculated my moment of inertia of all bodies, and then I added them, so that I got this one, isn't it? Now from there I found that YC also for the section, right? So I found centroid of this section, first section, centroid of second section, centroid of third section, and then from the 3 I got the centroid of the whole section YC. Okay, so YC is equal to, it is 55 we got, isn't it, guys? 55 we got, right? Now so from there I found my moment of inertia of this section, about Ixx I have found. Okay, so I hope everybody understand, right, guys? This is about moment of inertia of basics. Okay, I have explained you that basic shapes of moment of inertia, that is rectangle, triangle, circle, and halo circle. In the halo circle we have seen one more model, that is a thickness model. Okay, so all these things you are supposed to by heart. Now let me introduce you that the features of IMS GATE Academy, right? Now here these are all our toppers, GATE aspirants IMS from the GATE Academy, that are GATE 2023 success stories. Okay, now here all India rank, so if you observe that so many all India ranks below 100, but I just placed here few ranks which are two digits, that is all India rank mechanical, so third rank, all India rank fourth rank, all India fourth rank in CS, all India fourth rank in production and industrial, all India fourth rank in ES, and all India fourth rank, seventh rank in mechanical, and again all India ninth rank in mechanical, all India 10th rank in PI, all India 17th rank in ECE, all India 15th rank in EEE, all India 19th rank in civil engineering. Okay, now these are all our success stories. Please join with us, subscribe our channel, and look into our content as well as the faculty, so that you will be definitely impressive, and you will be able to experience the what GATE content is and what GATE exam all about is. Now here these are the features we are providing, that is 800 hours live sessions with interaction. Now 130 plus online tests and 20 to 30 theory books as well as the exercise books. What is a theory book and exercise book? Theory book explains the concepts, and exercise book gives you the questions. That questions are equipped with level 1, level 2, level 3, right? So in the level 1 we will find the basic, and in level 2 you need to apply logic. In level 3 you need to keep your all effort in order to solve the question, right? Now here 12 one-to-one mentorship programs, right? Now revision sessions and more. So why you are waiting? So take a turn towards the IMS GATE Academy, join with us. We are offering that physical classes and hybrid classes and online classes as well. Hybrid classes means 70% is online and 30% is offline. Okay, so this is what we are offering, right? Now thank you all, guys. Thank you very much. If you want to for contacting us, you may contact these numbers which are placed over here for different centers. We have in Bangalore, Vijayawada, Nagpur, we have placed the contact numbers. Contact this and join with us, and so that you will be able to enjoy the GATE courses. Thank you all.